Good morning, my name is Seok. I am a PhD course student of Department of Computer Science at Donggun University. The topic of my paper is predicting and compared network changes using neural networks. Many devices operate on various purposes using network technology, but unmanagement network environments cause packet loss for a variety of reasons. So, in this paper presentation, I will be describing for predicting network change using neural networks and demonstrates the predictability by predicting changes in neural networks. This presentation consists of 6 chapters. First, I will introduce the paper and related works. In addition, introduce the analysis of the experimental data and the experimental method. Finally, the result of the experiments and the subsequent study are mentioned. In recent years, as the IoT environment in which many devices are connected to the networks, so increase the data traffic such as transmission delay is caused by traffic existing the network bandwidth. In particular, IoT devices that operate in a limited power and wireless network environment require less time spent on retransmission data and time which can reduce power consumption and extend the life of the device. This paper investigates the characteristics of network traffic and predicts future network traffic in order to maintain optimal network conditions at all times. Predictable indicators necessary for network traffic prediction are determined by using the amount of data measured in the actual network, and the method of predicting it will allow the neural network to predict future network changes. Method for always transmitting existing network traffic in an optimal state have already been applied. First, BEV algorithm. BEV algorithm is used in IEEE 802.11 wireless local area network. This algorithm calculates the latency to prevent packet collisions between different nodes. Second, CSMA with CA and CSMA with CD. This algorithm is also used to prevent packet collision between different nodes. For example, CSMA with CA prevents collisions by sending RTS and CTS message before sending packets. Last, congestion control algorithm. This algorithm is used by TCP. TCP calculated the maximum data size that can be transmitted, hold the congestion window. However, because this method changes after a collision or loss, this transmission and delays occur for data that has already been lost. For stable and fast data transmission, the delay caused by retransmission must be reduced. In particular, technique for estimating network traffic change to reduce the loss of data generated beyond the allowable bandwidth of the network have been proposed. There are two existing ideas in this regard. Smart experts for network state estimation is machine learning based on EWMA equation. MLP network prediction algorithm use multi-layer perceptron to predict future network traffic. However, these techniques are difficult to apply to various real networks because they are predictable techniques under limited network conditions. This paper presentation on experiment that analyze changes in network traffic and predicts them. First, in order to analyze time series data such as network traffic, it is decomposed into each time series component to determine whether it is predictable. Among variable decomposition methods, STL decomposition has a powerful ability to decompose time series data into seasonal, trend, and reminder. After analyzing network traffic using STL, the actual future network traffic prediction will be experimented with LSTM, a kind of recurrent neural network. Cyclic neural networks are widely used for classification, prediction of time series data types, where old values often affect new values. LSTM long short-term memory models use input-output forget 3 types of gates to select the data for input-output hidden layers. Input gate determine how much of the data entered into the neural network. Output gate regulates the output of the neural network. Forget gate determines the reflection ratio for the immediately preceding data. The experiment data and analysis to be used in the paper are as follows. The network traffic data used in the experiment utilizes the time series data library. The TSDL provides a variety of the time series data, and this paper uses data measures for 55 days from a private European ISP. This figure shows a graph of measured data every hour. The x-axis time, the x-axis the time, and the y-axis the amount of network traffic. This figure shows the result of STL decomposition of data using R. Seasonal repeat about every time. And the trend trend repeat 5 rise and 2 declines. This means it's going up during the week and going down on the weekend. For the simulation program MATLAB 28B model and deep learning toolbox, for comparison of the traffic changes predicted by LSTM, the results are compared with those predicted by feed-forward neural network. This figure is the result of LSTM. In the graph above, the blue line is observed network traffic, and the red line is the predictive value. It can be seen that the observed and predictive values are almost identical. The graph below shows the error between observed value and predictive value. This figure shows the result of a feed-forward neural network. As in the previous graph, the blue line is the observed value and the red line is the predictive value. It can be seen that the observed and predicted values are very different. Root mean square error is used to compare the prediction performance of two neural networks. In the RMSE, theta is an observation. Theta hat is prediction. The calculation result using RMSE shows that LSTM has lower error than feed-forward neural network. In all nodes share the same network resource, they can prevent the delay caused by collisions, but they are not efficient because they waste idle network bandwidth. In addition, because they share a 2.4 GHz channel, the ISM band used by most IoT devices, wireless network has very high packet collisions or interference. In brief, solve the problem of using the fast network change to predict the time when network traffic is low and prolong the life of the device by communicating with the IoT devices sensitive to power consumption. Future research will increase prediction accuracy by varying parameters such as packet collision rate and latency, rather than predicting future network traffic based solely on the amount of data sent and received on the network. For example, most network protocol can recognize nodes on the same channel or on the same encryption scheme, but not on nodes using different protocols, adjust channels, or different encryption scheme. The problem is that the number and signal strength of nodes are used to recognize the network state using neural networks, and to reduce power waste such as retransmission by IoT device, using other channels. If there are no more questions, I will end my presentation here. Thanks for listening.